Revision on what we have learned last week. Okay, what we have learned last week is calculation of matrices. So what is matrices? It's a rectangular array of numbers. Okay, we say the order is the number of rows times number of columns, and then we have addition, subtraction, and multiplication of a scalar or two matrices together. So for calculations, if you want to add or subtract four matrices, you should have the same order. Okay, it must be a 3 times 2 and a 3 times 2 matrices, and they can add or subtract. When you times a scalar, like times a number, for example, 2 times the matrix A, you basically times all the entries by 2. Okay, times all the entries by 2. And then when you have multiplications of two matrices, the order does important. Okay, the order does important. The number of columns in the first matrices should equals to the number of rows in the second matrix. Just have a look at this example. This A times B, the number of column and the number of row are not the same, therefore A cannot be timed with matrix B. But if we do matrix B times A, then the number of column and the number of rows are the same. So they can be times together. When I have the matrix C as the result will become a 4 times 3 matrix. Okay, 4 times 3 matrix. And when you do the multiplication of the matrix, you use the row for the first matrix and the column of the second matrix. You use row 1 to times column 1, the result will be row 1, column 1. You use row 1 times the column 2, that will give you row 1, column 2. Okay, the result will be written in row 1, column 2. So that's the rule for addition, subtraction, and multiplication. And today what we're going to learn is identities and inverse and determinants for 2 times 2 matrix. Okay, what we have learned is add, subtract, and times. Which calculation rule we didn't learn? We have plus, minus, times, and division. Okay, remember in matrices we don't have division. Okay, we cannot divide matrix. You going to the wrong room? Yeah, just come in. Okay, we have add, subtract, and times. We won't have division. Okay, we don't have matrix. Don't have A divided by B. Okay, we don't have that. There's no division for matrix. Okay, there's no division for matrix. So if we can't divide by B, okay, so let's say in numbers, let's say we have A divided by B, okay, in numbers. So that equals to A times what? A divided by B equals to A times 1 over B, yes. Okay, we divide something equals to the times the inverse of that number, right? We divide by 2, it seems as we times 1 over 2. Divide something same as times the inverse of it. So that's how we calculate matrix. Okay, that's how we calculate matrix. So we divide something. If I can't divide, I can times the inverse. So instead of division, we will talk about divide the inverse of a matrix. Okay, I will show you some example later. Let's have a look at the square matrix. Okay, so some definition first. What is square matrix? So square matrix is a matrix with the same number of rows and columns are called square matrix. So basically it's n times n matrix. Okay, square matrix is n times n matrix. You have same number of row and same number of column. So instead of rectangular, you will have a square matrix. Okay, a square shape. Same number of rows, same number of column. And what is identity matrix? What is identity matrix? Identity matrix is a square matrix. Okay, first, identity matrix must be a square matrix. Like, if you have a 3 times 4 matrix, it cannot be identity matrix for sure. It must be an n times n matrix first. Okay, identity matrix is a square matrix. And identity matrix has element 1 on the main diagonal. But but 0 anywhere else. Okay, let's have a look. For a 3 times 3 matrix, the identity matrix use I to represent, and you have 1 on the main diagonal. Main diagonal is from the left top to bottom right is the main diagonal. Okay, that is the main diagonal. So only have 1s on the main diagonal and all 0s elsewhere. That's a 3 times 3 matrix. Okay, 3 times 3 matrix. Okay, so if it's a 2 times 2 matrix, then the square matrix, identity matrix will be that. If it's a 4 times 4 matrix, then you will have that. Okay, have 1 on, oh no, that's just a 0. You only have 1 on the main diagonal and 0 anywhere else. Okay, so what's the special thing for identity matrix? This identity I will be same as 1 in number, okay? Same as the number 1 in number. So any number times 1 equals to the number itself, right? 1 times any number, like 1 times 4, 5, 6, also equals to the same number there. Okay, so in matrix, that will be the same. Any matrix times the identity matrix will be the same as identity matrix times I times the A matrix. That will also equivalent to the original matrix. So basically, one matrix times with the identity matrix doesn't make any change. Okay, that matrix times I will still equals to that original matrix. So times the matrix I doesn't make any change. Okay, next one is inverse matrix. Okay, first give me a definition about what is inverse matrix. Let's say in number, what is inverse number? I say we have a number 4 over 3. What's the inverse number? 3 over 4. Okay, so if I have 1 over 2, what's the inverse? 2. So what's the important thing, like what's the special thing for inverse numbers? What's the definition? Do you remember, like maybe that's in year 7, year 8? What's the definition for inverse numbers? Well, you are not only flip the denominator and yes, the way you find the inverse number is you flip the numerator and denominator. But when you times them, what that can give you? When one number times its inverse, give you 1, right? 2 times a half give you 1. 3 over 4 times 4 over 3 give you 1. So if a number times its inverse, that will give you 1. That's the definition. Okay, a number times its inverse, that will equivalent to 1. So as I said, the inverse of a matrix, like the identity matrix I will be the same as the number 1 in numbers. So therefore, if I have a matrix A times the inverse A inverse, okay, let's use A minus 1 represent A inverse, that will give you identity matrix. And if I use inverse to times this A, that will give you identity matrix as well. Okay, so how, like, what is identity matrix? What is inverse matrix? So inverse matrix times the original matrix should equals to the identity matrix. So that's the definition. Okay, that is the definition for any matrix. Okay, any matrix. So doesn't matter it's 2 times 2, 3 times 3, or 4 times 4. This definition will always be true. Okay. For inverse matrix in high school, we only think about 2 times 2 matrix and its inverse. We don't really find inverse for 3 times 3 matrix. And another thing you must remember is inverse matrix only if A is square matrix. Okay, A will have inverse only if A is square matrix. So in other words, a 3 times 4 matrix will not have inverse matrix. A 3 times 4 matrix will not have inverse matrix. Okay, so only square matrix will have inverse matrix. Okay, only square matrix will have inverse matrix. So in uni, okay, if you learn some math subjects in uni, like first year, you will learn one way to find all the inverse matrix. Okay, I still remember, it's quite fun. Okay, I think matrix is quite fun in uni level, but like now it's like we only use for transformation. It's not that helpful. So in uni, you learn one method, which is like a more mature way to find inverse. But now we only consider 2 times 2 matrix. We don't really use that method. We use a formula to calculate the inverse for 2 times 2 matrix. Okay, for 2 times 2 matrix. So this formula only works for 2 times 2. Okay, only works for 2 times 2. So if you have a 3 times 3, it doesn't work. Okay, we can't use 3 times 3. But we won't ask 3 times 3 inverse. If we ask, you use calculator to find. Okay, if we ask, use calculator to find that. Okay, so if I have matrix A, B, C, D. Okay, I have matrix A, B, C, D. Okay, A is here, B is here, C is here, D is here. Okay, in this order. Okay, order is important. So A, B in a row, C, D in another row. So what is A inverse? A inverse, okay, it's a long formula, is 1 over AD minus BC. Okay, first I have a scalar. That's a scalar factor. First, we'll create a scalar factor AD minus BC, which is the main diagonal subtract the other diagonal, okay, times, okay, times the main diagonal subtract the other diagonal. And then we'll have, and then inside the matrix, what we'll do is, we will have, okay, change the order for the main diagonal. Change the 2 numbers on the main diagonal. Okay, you can see AD here. Now this one becomes DA. Change those 2 numbers. Okay, change the order of those 2 numbers. And then I will negative the other diagonal's number. Okay, can you see the order doesn't change, but I'll negative that. I'll negative that. So 3 things to do. First, I will find the scalar factor. Second, change main diagonal. Third, negative the other diagonal. Okay, change 3 things to do, okay, to find inverse. Okay, to find inverse of 2 times 2 matrix. Okay, to find inverse of 2 times 2 matrix. So find the scalar factor, which is 1 over AD minus BC. So AD is the main diagonal, BC is the other diagonal. So always change the main diagonal in the front, okay? Always the main diagonal. Main diagonal is the left to right, okay? Left to right. And change the number on the main diagonal and negative the other diagonals. I think you have competitions.
Sorry?
Oh, I think you have competitions on campus. Oh, it's not the spirit. Oh. Okay, so let's have a look. So determinant. So what is determinant? Okay, I have a question. Do you think every 2 times 2 matrix will have inverse? Is that a correct statement? Why not? Like just look at this formula. Okay, everything we'll look at from this formula. So here, in which case you won't have an inverse? Yes, if determinant 0, or let's say if the denominator is 0, AD minus BC is 0. Like I can always swap the main diagonal. I can always minus the other diagonal. But the only problem may occur is the determinants, like the denominator at the bottom. If you have a 0 denominator, you won't have this matrix. Okay, you won't have the inverse matrix. So what we decide is the bottom, AD minus BC here. Okay, AD minus BC here. So determinant is AD minus BC. That's why it's called determinant. It's like determine whether you will have inverse or not. Okay, whether you will have inverse or not. So you basically follow that formula, but you will see the determinant, okay, AD minus BC. So if determinant not equals to 0, A inverse will exist, and A is said to be a regular matrix. Okay, you have a regular matrix. You have inverse, it's a regular matrix. If doesn't exist, you will have is a singular matrix. Okay, it depends on whether A inverse exists or not. If A inverse exists, then it's a regular matrix. If A inverse doesn't exist, then it's a regular singular matrix. Okay, regular and singular matrix. Okay, examples. For the matrix A equals to 3, 2, 1, 6, that's a square matrix. Okay, first you see that's a square matrix. That's a 2 times 2 square matrix. Okay, that's a 2 times 2 square matrix. Find the determinant of A. Okay, that A. Determinant of A will equals to the main diagonal